for us also, just so you have this recorded. Okay, a lot of this should be review from last year. We are going to get a little deeper, especially with like graphing inverse trig functions. And a lot of this we'll come back to you. But today's stuff is all going to be pretty basic, as it says here, basic trig review, right? So you guys should know the 6 trig functions: sine, cosine. You don't have to write these down, by the way. I mean, I'm just writing for my own reference. Tangent, cosecant, secant, and cotangent. I know my handwriting really stinks here. Do you know why sine and like why we use the word co? Does anyone know what the word co stands for? What's it short for? Thank you. Yeah, yes.
The co stands for complementary. The sine of 30 degrees, which I know is 1/2. The cosine of 60 degrees, also 1/2, right? What's 30 plus 60?
90. So these are going to be complements of each other. So when these are equal to each other, the angles are complements to each other. Likewise, if I did tangent of 30, tangent 30 is what? 1 over root, no, I should know this, 1 over root 3. The cotangent of 60 would also be 1 over root 3. So those are also complements. Likewise, the secant and cosecant. So they're just complements of each other. And of course, SOHCAHTOA, you guys are comfortable with that, right? Okay, we're good. Let's talk about standard position of an angle. So standard position of an angle always lies on the positive x-axis, and you rotate counterclockwise in the positive direction. So positive direction rotates counterclockwise. CCW is short for counterclockwise, and negative would be clockwise. So CW is short for. I'll do a little key here because I don't want to keep writing this over and over again because it's really a pain to write. But just CCW stands for counterclockwise, and CW stands for clockwise. So if you start here and go this direction, so we call this the initial side. We call this the terminal side, where you end. And we call this theta. Get used to that. We use that all the time, theta. Quadrants, how are the quadrants labeled? Like where would the first quadrant be? Top right. Yeah, I don't know why that's the case, but it just is. And it goes counterclockwise. 1, 2, 3, 4. Right, we know this. If you go the other direction, that would be a negative angle, right? But of course, in this direction, that's a positive angle when you go counterclockwise. I think that's all I need to say about that for now. Okay. Any questions? No? Okay. Coterminal. What does it mean when something's coterminal? Not complement. The code's different actually in this case. Go, Captain. Same, yeah. So think about let's do a play on words. Play on words here. Like, what if you have a co-pilot, right? You have 2 pilots. We have co-captains. You have 2 captains, right? So code means the same or multiple, right? Now, terminal means ending. It sounds kind of morbid, like if you have a terminal illness, that's not good. You're probably going to die soon. We're all going to die, but if you have something, you have disease, I don't know. Okay, or something more cheerful, like airport, right? You're at airport. You have the terminal at the airport, right? What's a terminal at the airport? That's the end of the airport. Because what happens? You get on the plane, you go, right? And hopefully the plane doesn't crash, but you die again. No. Anyway, the airplanes are very safe. They're very safe. So that's just a play on words. So in this case, coterminal 120. So let me draw 120 first. 120 would look like this roughly, kind of eyeballing a little bit. You could use a protractor if you want to, not necessary. So if I want to be coterminal, I have to go around once at least, right? Actually, let me make it a little smaller.
Negative 2.
You could negative also, exactly right. Hold on, I just want to color code this appropriately. Yeah, I'll use green for going the positive direction. So I can go around once. and stop here. So if I've gone around once, how many degrees have I traveled in one revolution?
360.
Then plus the extra 120, so that's 480. So if I go the other way, so you don't quite go a full revolution the other direction, you stop short by 120. So instead of going 360, you stop short by 120. So it's 240 degrees, or sorry, negative 240. Seriously, just add or subtract 360. That's all you're doing. Of course, we're going to be doing stuff in radians, so it's not going to be always degrees, just, you know, but for now we're doing degrees just to get you guys warmed up a little bit. Speaking of the devil, let's talk about radians, right? Let me do this little spiel here for you guys. You don't have to write this down. This is more for your own reference. Does anyone know why we have that conversion 2 pi radians equals 360 degrees? Does anyone know where that comes from? So think about like plain geometry. Yeah, all right, go.
Oh, well, like if you do what was it, 1 radian of an angle, then I think that equals 1.
The arc length.
Yeah.
The arc length, yes. So R is on the right track. It's going to deal with arc length and proportional reasoning. It's all about proportional reasoning. So where do radians come from? Radians. It's all about proportional reasoning. So let's, and again, you don't have to write this down. This is just more for your own reference. So let's just say, for example, I have this, right? And let's say this is 2 and 2, and say it's 90 degrees. And I want to find the length of the arc here. How would I find the length of the arc? What would that length of that arc be? So we have 90 degrees, sure. And so what fraction of the circle are we talking about?
2 pi r.
Yeah, you're dealing with 1/4 of a circle, right? 1/4 of a circle. And what's the circumference, by the way?
2 pi r.
2 pi r, or in this case, 2 pi times 2, which of course is 4 pi. But you only have a portion of it, right? So it's pi. So the length of that arc is pi. And pi is roughly what number? 3.14, right? Now, let's reduce this angle. Let's just reduce this angle just by a little bit. So let me reduce this a tad. What if I two and 2? Could this arc have a length of 2? Sure, why not? Of course it can. There's no reason why the arc can't be the same length as radius. When that happens, theta equals 1 radian when the arc length, so yeah, R is definitely on the right track. When the arc length, you gotta look at the arc length, equals a radius. When that happens, we say the central angle is 1 radian. That's the definition of 1 radian. How does this relate to degrees, though? That's a whole other story. Okay, but for now, that's what you gotta know. Theta equals 1 radian when the arc length equals a radius. When the arc length is the radius, great. Or more generally speaking, we'll just do this, right? Let's call this R and R, radii, right? And that's R, right? So when that happens, theta equals 1 radian. Now, this is the part that's important. Very important. This is the connection to degrees. Okay, so a full circle is how many degrees again? 360 degrees, right? Also, the length of a full circle. What do we call the length of the full circle? What term we use? What do we call that? The length of the full circle. It's a circumference, right? 2 pi r. Okay, we're going to do proportional reasoning. The arc length divided by the central angle, or actually, let me write the ratio a little differently. The central angle, which is theta, right? Divided by 360 degrees, wouldn't that equal the arc length divided by the circumference? Do you guys agree with that statement? Yeah, hopefully that makes sense, right? Because think about it. This central angle divided by 360, whatever fraction that is,
is proportional to the arc length and the whole circle, right? The whole circumference. Yes. We saw that with 90 degrees, right? You had 90 degrees, 90 over 3/6, 1/4, and that arc that I had originally was 1/4 of the whole circle and had 90 degrees.
But in this case, we're dealing with the radian now. So my central angle in this particular case, for this green circle that I just drew, that's 1 radian, right? That's my central angle, right? Divide by 360 degrees. What's my arc length in this case? What's the length of my arc right now?
Just R straight up, right?
And what's my circumference? 2 pi. Do things cancel? Absolutely. These r's go away. So that becomes 1 over 2 pi. Cross multiply. 2 pi radians equals, guess what? 360 degrees. This is why the conversion exists the way it does. This is the reason why. And it's recorded, so you can watch whenever you want. But this is why it happens. Sometimes we want to keep things simpler. We could just divide everything by 2. So you can see pi radians equals 180 degrees. So some students just memorize this and they never know why. And it's kind of sad because, you know, maybe a teacher didn't emphasize it. I'm not saying Ms. Long didn't emphasize it, but I just want to make sure you guys know. This is why pi radians equals 180 degrees, or 2 pi radians equals 360 degrees. It's all proportional reasoning. So that's my little spiel on it. Okay, now let's look at the notes. And I fill out whatever we need to fill out. Okay, what do we got here? So looking at the notes, we'll just kind of fill out the stuff. Yeah, there are 2 pi radians and 1 rotation around the circle. We know this already, right? And then unit circle, we say when we talk about the unit circle, we talk about the radius 1. We're going to talk about unit circle today. That's a big deal. And you need to know that relation between radians and degrees. Totally, that's very important, right? So 2 pi radians in 1 circle, then therefore 2 pi radians equals 360 degrees. We already talked about this. We know this now, right? Don't know why that circle is there. Let me scroll down. Yeah, anyway, we'll just keep moving. These notes look a little different than what I have here. All right, cool. Trig functions and unit circle. All right, so the unit circle, right? And we're going to fill it out on the next page. And I have kind of an interesting way. Do you guys have it memorized, unit circle? Or do you understand it? Or do you know how do you know the process of how to fill it out?
Yeah.
Okay, I'm gonna kind of show you my way also. I mean, maybe your way's just like mine or a little different. But before we get too deep into it, when you have the unit circle, actually now I know why the circle's here. Sorry guys. Now I know it's here. I see it in the note. So what if I have some terminal side like this, right? And my initial side's like this. And this is theta, right? We'll call it theta. And what if I drew, shoot, need more, let me make it like that. That's theta. And what if I drew a right triangle like this? I'll superimpose it over here. I'll superimpose it like that. Okay. So this right here, the hypotenuse, is the same thing as the radius of the circle, right? In fact, actually it's 1, right? Because you have a unit circle. Radius equals 1 for the unit circle. And I'm going to call this x and y. Naturally speaking, because x is horizontal and y is vertical. What relationship or equation can I generate from this triangle here? Pythagorean theorem. And so what would that be if I apply Pythagorean theorem to this? X squared plus y squared equals 1. That's also the equation of the circle, right? That's the equation of the circle. X squared plus y squared equals 1. So that we see a lot of connections now between plane geometry and coordinate geometry and right triangle geometry. Right? A lot of connections here. Let's talk about SOHCAHTOA. With that, with that knowledge, so x, y, 1, and with the knowledge of SOHCAHTOA, yeah, let me position it. So TOA. So O over H is opposite of hypotenuse, A over H is adjacent hypotenuse, TOA is opposite of adjacent. You could have your own acronyms too. Does anyone have an interesting acronym they want to share about SOHCAHTOA? That doesn't. The way I learned in 6th grade, Oliver has a heap of apples. Not sure that makes sense. I don't know why. When I was 11 years old, it made sense to me. So there we go. So 34 years later, that's why. But opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So what this means is that if I have x as my adjacent, y is my opposite, and 1 is my hypotenuse, the sign is going to be y over 1. Or technically speaking, y over r. Right? We should probably, well, we'll just do y over 1 for now. We'll do r at a later time. We'll call it y. Cosecant is going to be flipped over, right? Because it's just reciprocal. So cosecant theta is reciprocal sine, so that's 1 over y. Next up, obviously cosine is adjacent over hypotenuse, that's x over 1, or just plain old x. So you flip it for secant. So the secant is going to be 1 over cosine. And then tangent is opposite over adjacent, which is y over x. So the cotangent is x over y, because it's 1 over tangent is cotangent. And of course, these are all reversed for the other guys here too. 1 over secant's cosine, 1 over cosecant sine. Okay, all makes sense? We're good? But just so you know,
Once we start dealing with non-unit circle stuff, like we start doing other kind of circular functions, you're gonna have to treat that as bar. You know, but for now we use one, is raised one. But we don't want to get confused. I'm sure you guys will be fine.
so I'm not worried about it. It's usually other pre-calculus classes, they sometimes get that confused. Okay, unit circle. Here we go. Okay. So let me talk about how I prefer to do this. I just start by putting all the degrees in. Just that's kind of easy because it's intuitive, right? So you always start here. And you go this direction, that's a positive direction, right? As you said, counterclockwise is positive. So that's 0 degrees. That's 90. You know, I think I gotta stat it. There we go. I might bet. Okay. Let's get in here. 180, 270, and 360, right? We're okay at that so far? And then let's look at the first quadrant. In the first quadrant, if you got a protractor and measured it, you just have to trust me. This is 30 degrees. That's 45 degrees, and that's 60 degrees. And if you use a bit of symmetry, you can figure out the other angles, right? For example, what would be the next one after 90? I'm sorry, 120, right? Because reference angles, right? If this is 30 from here to here, that's 30 from here to here, right? So it's just all about reference angles. 150. Oh, sorry. Wow. I just failed. 135 and 150. So I keep going, 210, 225, 240, 300, 315, 330. Okay. So hopefully those all make sense. As long as you know the first quadrant, the rest are all relative, just using reference angles. Like technically a reference angle is the acute angle from the terminal side to the x-axis, but just referring to the y or x-axis, how close it is, you want that symmetry on the other side, right? Okay. We'll get to coordinates in just a little bit. Let's talk about radians now. Now, if you want to actually, excuse me, convert all those to radians, go for it. By the way, the conversion is this. To go from degrees to radians, you take theta and you multiply by pi over 180. You could do that for each one. It'll take you a while. You could do that. Let me show you a better way. I'm going to erase this. I'll show you a better way. You know that this is 0 radians, right? When we start. And we know it ends at 2 pi, right? Use proportional reasoning. 180. 180 is half of 360. What's half of 2 pi? 90. 90 is half of 180. What's half of pi? Pi over 2. Or 9 is 1/4 of 2 pi. Or 1/4 of 360, which is pi over 2. Okay. Let's look at the first quadrant. Let's look at 30.
30 is what fraction of 180?
That's it.
5 or 6. 45 is what fraction of 90?
5 or 4.
So 45 is half of 90, half of pi over 2 is pi over 4.
Or fourth of 180. 60. Isn't 60 double 30?
Or a third of 180?
Pi over 3. Okay, 120. 120 is what times 60? What do you multiply 60 to get to 120? So 2 pi over 3. 135 is 3 times 45. I'm using proportional reason. I'm not doing any of that silly conversion pi over 180 crap. 150. 150 is what times 30? 5 pi over 6. Eventually you'll get the hang of it. 210 is 7 times 30. 225 is 5 times 45. 240 is 4 times 60. 300 is 5 times 60. 315 is 7 times 45. 330 is 11 times 30. That's how I like to think of it, like that. Oh, and 270 obviously is 3 pi over 2. That's 3 times 90. So there you go. So that should help in generating the unit circle from scratch, right? Because I'm not going to give it to you guys. I do give it to Atlo Precalculus. Sometimes my top precalculus I gave it. You guys got to know it really well, because you got to be able to recount the stuff quickly in AP Calculus A, B, or BC, whichever one you do next year. Coordinates. Let's talk about the coordinates. These are pretty easy. 1, 0, 0, 1, negative 1, 0, 0, negative 1, right? Easy peasy. Because the radius is 1, obviously. And the center's at 0, 0. Center's at 0, 0, radius of 1, use some logic, you get those coordinates. The ones in the middle utilize plane geometry, right? So we have two special triangles, right triangles. We have a 30, 60, 90, right? We know this. And we also have 45, 45, 90. For 45, 45, 90, that's S, S, and S root 2. For 36, 90, that's S, S root 3, and 2S. So you guys should know those, should be pretty comfortable with those ratios. You guys are comfortable with those ratios? Have them locked in your head? On the SAT, I think they give this to you. ACT, they do not. ACT does not give this. Because calculator, of course, but with that knowledge, let's look at 30 degrees. If this is 1 and that's 30 degrees, how long is the vertical leg? 1/2. How long is the horizontal leg? And that's going to coincide with this coordinate plane, right? It coincides. So clearly I'm going root 3 over 2 to the right and 1/2 up. So this means that 60 is going to be reversed, right? If you tilted that right triangle or just simply reverse the coordinates, that's what you get for 60 degrees. Remember, the complements of each other, right? The sine of 30 is cosine 60, right? Or the cosine of 30 is sine 60, and so forth. And then finally, for 45 degrees, about 45 degrees here, right? Let's say the hypotenuse is 1. This is always a little tricky. The hypotenuse is 1. What are the side lengths? The legs. Yeah, because if you could do Pythagorean theorem if you want to, or divide by root 2, exactly. So 1 over root 2, 1 over root 2. Or some people like to do root 2 over 2 if you rationalize the denominator. I actually don't care if you rationalize the denominator. It doesn't matter to me. But we'll do root 2 over 2. That's true for both. At this point, how are you going to do the coordinates for all the other stuff? Yeah, plus or minus, exactly right. If you're in the second quadrant, clearly, I'm not going to write it out because you guys get the point. But clearly, x is negative. X is negative in the second quadrant. Y is positive. Here, x and y are both positive. Here, of course, x and y are both negative. And here, X is positive, Y is negative in the fourth quadrant. Let me clear out some of the stuff here. Cool. So anyway, what this tells us is that when you're at the first quadrant, all trig functions are positive. None are ever negative. In the first quadrant, because y is positive, y goes to sine. Sine and cosecant are positive. Cosine, secant, tan, and cotan are negative. What's positive here? Only tan and cotan, because you're dividing two negative values, x and y. Here, cosine, secant. And of course, you do the counterparts. Sine, cosecant, cosine, secant, sine, cosecant, tan, cotan are negative. So one way you can remember this, ASTC, you can say all students take calculus, all students take chemistry. One of my sophomores many years ago said aardvarks sleep towards California. I don't know. It's still, these weird things stick in my head. So don't mind my bizarre acronyms here. So anyway, but all students take calculus, go counterclockwise. So this will help when you have to regurgitate, like, okay, give me, the sine of like 240 degrees. You want to be able to, okay, so it's in the third quadrant, it's going to be negative, right? Because it's y. So you want to be able to think of that quickly. And of course, getting the coordinates as well. So that's the unit circle in all its glory. Questions at all? No? Okay. I already did special right triangles, so I'm not gonna fill that out again. Okay, this is the last thing we'll do. I'm gonna end page 4 and then give you guys a head start on homework. Yeah, this is kind of a pain in the ass, but let's just do it. Let's get it done quickly. So 0, 5 or 6, 5 or 4, 5 or 3, 5 or 2. You get the point. 2 pi over 3, 3 pi over 4, 5 pi over 6, pi. X, of course, is 0 and 1. Sorry, I can't believe I just did that. 1 and 0. And that's going to be negative 1 and 0. That's 0 and 1. That's going to be root 3 over 2 and 1/2. 1/2 root 3 over 2. Negative root 2 over 2. Negative root 2 over 2. Tangent's y over x. So that would be 1 over root 3.
Why is 45?
Why is it negative?
I don't know. I did negative. My apologies. I don't know. Couldn't tell you. All right. Okay. Yeah, so tangent's 1 over root 3. So then you just flip all the other guys, right? 2 over root 3, 2, and root 3. I don't care if you rationalize the denominator. It doesn't really matter to me. Here, this will be, tangent will be 1, but secant's 2 over root 2, 2 over root 2, and that will also be 1. And by the way, 2 over root 2 is root 2, in case you're curious. Those are actually just root 2. And then, of course, here, this is root 3. But then that would be 1 over root 3. And that would be 2 and 2 over root 3. Tangent here is undefined. And secant's also going to be undefined. Cosecant will still be 1, and cotangent will be 0. And then you just kind of reverse things. It's just all the coordinates, right? Like that's, we won't do, you know what? I don't want to torture you guys. We won't go below 180 because, or past 180 because, you guys get the point. But just so you see the negative changes, right? So like that's negative 1/2, negative √2/2, and negative √3/2. And this will be negative √3/2. Nope, it's positive. My bad. √3/2, because symmetric, √2/2 and 1/2. Tangent changes sign though. Negative √3, -1, -1/√3. The cosecant stay the same as before. 2/√3, √2, and 2. These will change sign. -2, -√2, -2/√3. These change sign. -1/√3, -1, -√3. Tangent 180 is 0, but it's undefined for here. And of course, that's -1, that's 0. Nope, undefined. There we go. And up top, I didn't do this, but that's 0. That's 1. Undefined. Undefined. Okay. Yeah, I'm not gonna make you guys do the rest. You guys get the idea. All right. So homework. Let's talk about what homework's going to be like. Let me pass it out, and I'll stop the recording.